Assalamualaikum. Hi everyone. My name is Aifa Alifa binti Ahmad Nazri. So I would like to present about the example of 7.13. Okay. This example is show about the system identification. From this example, the problem of finding the system description from knowledge of input and output is known as system identification. Find the transfer function and impulse response of a causal LTI system if the input to the system is xn is equal to -1/3 to the power of n multiplied by unit step n, and the output is yn is equal to 3 multiple -1 to the power of n multiple unit step n plus 1/3 to the power of n multiplied by unit step n. Okay, from this problem, we need to find the causal LTI system, which is Hn, and then this question give us the input of the system, which is Sn, and the output of the system, which is Yn. Okay, so for the solution, first we need to do the Z transform for the input and output system. So we do the Z transform for the input, which is we will get Xz is equal to 1 divided by 1 plus 1/3 multiplied by Z to the power of -1 with ROC, region of convergence, Z is bigger than 1/3. How do I get the previous result? We know that we have Xn signal. We do the Z transform, we will get Xz. So this Xz is equal to the summation from n to the power from n is equal to -infinity to infinity of the dsn multiple by z to the power of -n. So from the equation, we know that Xn is equal to -1/3 to the power of n multiplied by unit step n. So we apply this equation. We just substitute this Xn into this equation. We will get Xz is equal to the summation n from the -infinity to infinity, -1/3 to the power of n multiplied by unit step n multiplied by z -n. Just substitute the Xn into this, we will get this. So we know that if there is unit step, for all value or integer that negative, we will get no result. We will get 0 result. So from this, for the unit step, we just do the summation from n is equal to 0 to the infinity. So we will get the summation of n is equal to 0 to infinity, -1/3 to the power of n multiplied by z -n. And then just take out the n, factorize it, we will get -1/3 multiplied by z to the power of a -1 in the bracket to the power of n. So when you expand this, when you put the value of n from starting from 0, we will get the answer 1 plus and then we put n, the value of n is equal to 1, we will get -1/3 multiple z to the power of -1 in the bracket to the power of 1 plus -1/3 multiplied by z to the power of -1 in the bracket to the power of 2 and so on, because it's going to infinity. So we use the infinity summation of equation, which is the first term will divide 1 minus of common ratio, and it is valid for the modulus of common ratio less than 1. So we know that so from this it will we will get the xz is equal to the first term of the summation, which is 1, divide by 1 minus of CR, which is negative 1 over 3 of z negative 1 of z to the power of negative 1. This is CR. So minus negative, we will get plus with ROC of z is bigger than 1 over 3. So how I get this value? We know that this is valid for the CR is less than 1. So just substitute the value of CR, which is modulus negative 1 over 3. We will get positive 1 over 3. Multiple by z to the power of negative 1, which is over z is less than 1. Then we will get 1 over 3 is less than z, and z we will get z bigger than 1 over 3. So this is how I get modulus z is bigger than 1 over 3. So next we will do the z transform for the output. We will get this equation. So how I get it? How do I get it? So we know that we do the z transform for yn, we will get the yz. And the equation is same as the xn. We know that yn is equal to 3 multiplied by negative 1 to the power of n unit multiplied by unit step plus 1 over 3 to the power of n multiplied by unit step n. And then we just substitute the value of yn into the yz equation, which is the summation of n is equal to negative infinity from negative infinity to infinity. Just put this first equation multiplied by z negative to the power of negative n plus the summation n from negative infinity to infinity. Just put this equation multiplied by z to the power of negative n, and then the rest just follow as the previous solution. You will get this result: 3 minus 1 plus z to the power of negative 1 plus 1 minus 1 negative 1 over 3 multiplied by z to the power of negative 1. You get this result with ROC z bigger than 1. Okay, next, to obtain the transfer function, which is the LTI system, we use the transfer function equation, which is hz is equal to yz divided by xz. So we know that yz is equal to this as the previous answer, and then 1 over, and then the xz is equal to this. So just expand and summarize it, it will become like this. So we apply a partial fraction expansion to hz yields. We know that as previous, hz is equal to this with ROC z bigger than 1. We do a partial fraction expansion. We will get hz is equal to a divide by first bracket plus b divide by second bracket. So next, we need to find a first. So how to find a? A is equal to the hz is multiplied by the first bracket that dividing by a. And then we need to cancel this bracket. So how to cancel it? We need to put the value of z to the power of negative 1 is equal to -1, which is when we put it this into this, we will get 0. So we can cancel the first bracket. We can cancel the first bracket because it will become 0. So put this value to the other z to the power of -1. We will get this, you put -1, and then this also we good, you put -1. Then just calculate it. We will get a is equal to 2. Same as b, hz you must multiply the second bracket. And then how to cancel this bracket? We know that 1, we need to 1 minus also 1. So how to get this 1? 1/3. We need to put this value of z to the power of -1 is equal to 3. And then we cancel it. We will get 1. 1 minus 1 equal to 0. And then this bracket will be cancelled off. So just put the rest of z negative to the power of n to the power of 1 is equal to 3. So you will get the b is equal to 2. So just substitute the value of a and b into this equation. You get 2 to the power, you get hz is equal to 2 divided by 1 plus z to the power of -1 plus 2 divided by 1 minus 1/3 multiplied by z to the power of -1. So this is result shown as in the slide. It is proven. My answer is same as the in the slide. Okay, next. So to find hz, the impulse response of the to find the hn, the impulse response of the system is obtained by finding the inverse z transform of hz. How to find hn? We need to inverse the hz, inverse z transform of hz. So we know that hz is equal to this equation. Then we apply the inverse z transform. We inverse transform this, we inverse transform this. We will get the hn from hz, inverse transform, inverse z transform. We will get hn back. And then hn is equal to 2. This is -1. Multiple -1 to the power of n multiplied by unit step n as a previous, plus 2 multiplied by 1/3 to the power of n multiplied by unit step n. So this is the answer of the problem, the example of 7.13, how to find the causal LTI system, which is hn. So you can determine the hn as like this. Thank you everyone. Stay safe.